Okay, for question number 33, part A, it is given that the function f of x is equal to x raised power 4 minus 62x squared plus ax plus 9. This attains local maximum value at x is equal to 1. And we have to find the value of a. So let's find out the value of a first. And our function is given as this function is f of x is equal to x raised power 4 minus 62x squared plus ax plus 9. Okay, now this function attains local maximum value at, so x is a point of local maxima. So we can say that at x is equal to 1 is a point of local maxima. And we know that for the critical points, these are the critical points for local maxima or minima, the value of the function at that point is equal to 0. So f dash 1 should be equal to 0. And now let's find out f dash 1. So this is our function, and we have to find its first order derivative first. So f dash x is equal to, this is 4x cubed minus 62 into 2x plus a. And this should be now equal to 4x cubed minus, this is 2 to the 4, 124x plus a. Now, if we have to find f dash 1, we have to substitute the value of x as 1. So this is 4 into 1 cube minus 124 into 1 plus a is equal to 0. Okay, so this is 4 minus 124 plus a is equal to 0, which is negative 120 plus a is equal to 0, and a is equal to 120. So the value of a is 120, and hence obtain all of the points where the given function f of x attains local maximum. So we have got the value of a. So now our function becomes, so this is our function. Now let's substitute the value of a. So this function becomes, this is x raised power 4 minus 124 x raised power 4 minus 62x squared, or let's get the value of f dash x. So our function is now x raised power 4 minus 62x squared plus a is 120x plus 9. And now the first order differentiation is 4x cubed minus 124x plus 120. Now we have to find all other points where the given function attains local maximum, local minimum value. And now we know that for maxima or minima, f dash x should be equal to 0. So that means 4x cubed minus 124x plus 120 is equal to 0. Okay, here 4 is common. So this is now x cubed minus 41x plus 30 is equal to 0. Sorry, this is 4 3 is 12. So this is 31x plus 30 is equal to 0. So this is now x cubed minus 31x plus 30 is equal to 0 is our cubic polynomial, and we have to factorize this. So let's consider this p of x is equal to x cubed minus 31x plus 30, and value of this function at x is equal to 1 is 0. So this is negative 31 plus 30 is equal to negative, this is actually 1 minus 31 plus 30, which is equal to negative 30 plus 30 is equal to 0. So that means x minus 1 is a factor of this polynomial, that is x cubed minus 31x plus 30. Now if x minus is a factor of x cubed minus 31x plus 30. Then let's divide it with x minus 1 to get other factors. So x squared, we are using the long division method. This is x cubed minus x squared. Subtract them. This this is x squared minus 31x plus 30. And now it's plus x, which is x squared minus x negative positive minus 31x plus x is negative 30x plus 30. This is negative 30 and negative 30x plus 30. Okay, this is equal to 0. So that means now I can write this x cubed minus 31x plus 30 as x minus 1 is a factor, and the other factor is x squared plus x minus 30. And now we can factorize this x squared plus x minus 30. It can be written as x squared plus 6x minus 5x minus 30. This is equal to x minus 1 and x plus 6 minus 5 into x plus 6. Okay, this is equal to x minus 1 and x plus 6 is a factor, so this is x minus 5. Okay, so now this can be written as this is x minus 1, x plus 6 and x minus 5. X plus 6 and x minus 5. So that means either x minus 1 is 0, x plus 6 is 0, or x is equal to 5. Uh, x minus 5 is 0, which gives me x is equal to 1, x is equal to negative 6, and x is equal to 5. All right. So these are the points of local maxima or minima. These are our critical points. And now let's find out the second order derivative to check these are the point of maxima or minima. So this is f dash x, and let's find out the second order derivative. So second order derivative would be this. For this, it's 12x squared minus 124. Now let's check it for check the second order derivative is only for x is equal to 1. So this is 12 square minus 124, which is 12 minus 124, which is 0, which is less than 0. So x is equal to 1 is a point of local maximum. Sorry. Now let's similarly check second order derivative for negative 6. So 12 into negative 6 square minus 124, which is 12 into 36 minus 124, which is obviously greater than 0. So this is 12, 72, 36, 2, 13, and 432. So 432 minus 124, which is 12 minus 4 is 8, 0, 3, which is greater than 0. So that means x is equal to negative 6 is a point of local minima. Now let's check the second order derivative for the other critical point, which is 5. So this is 12 into 5 square minus 124. So 12 into 25 minus 125, 24, which is 50 into 25, which is 300 minus 124, 6, which is greater than 0. So that means x is equal to 5 is a point of local minima. So x is equal to 5 is a point of local maxima, whereas x is equal to negative 6 is a point of local maxima, and similarly x is equal to 5 is also a point of local minima. Sorry.